Welcome to this webinar, Accelerate Engineering Insights with Data Search, which is really about this. Data volumes in engineering are increasing. So how do you get value from all that data? This is an increasing problem we're seeing. And but before I introduce myself and talk about who we are, let me tell you the three things that we're going to cover today. Firstly, the scale of the problem that we're talking about with regards to the challenge of engineering data and why it's important. And also what it has to do with this number. Secondly, how you can use apps to make data analysis tasks achievable for more engineers. And we'll see how it relates to this process. And thirdly, how data search in Aqira helps you gain value from all this data being very configurable. And in that context, we'll look at this in action, the search designer. I'm John Aldred. I'm Director of Product Management at Prenscia, and we help engineers deliver durable and reliable products and avoid the cost of unexpected failures. And we do that through two ranges of software products, Encode for durability and ReliaSoft for reliability, and covering both the statistics and probability of failure as well as the physics of failure. And we do that through software and related services. Today, we're going to be covering a product called Aqira. So there's a range of ReliaSoft and Encode products that we provide. And today, we're going to be focusing on our web-based product called Aqira. So let's get started and look at an example where we see data volumes increasing. So here, for example, is some data from a European automotive OEM. In this case, we're talking about connected vehicles. So connected vehicles enable the transfer of data either continuously or intermittently, information on maybe the location of the vehicle, the diagnostics, and I see here from the maps provided the big increase in the number of connected vehicles. The latest status 2019 is for this manufacturer is that they have 2.5 million connected vehicles, and they have 1,500 connected engineering vehicles. So vehicles where there is more detailed data being collected, and in total, this company is analyzing 6 terabytes of data from these vehicles each year. A lot of that data is actually coming from those connected vehicles. 1,500 engineering vehicles is quite a large number. So that's one example. This ramp up in available data. In this case, from connected vehicles. Let's look at some other examples. In wind power, you're looking at a wind farm with, say, 40 wind turbines. That would be collecting 8,000 data files per year. And from those files, for every wind turbine, there'd be 200 different statistics that would be tracked either directly or calculated and in order to monitor the health or condition or operation of those wind turbines. So that's just for one 40 wind turbine farm. Also in generation, in this case hydroelectric, 2,500 turbines are continuously being monitored, generating data. And there are specific vibration tests that are conducted where every time they do a test, it generates 1.5 gigabytes of data, and they do that 100 times each year. So again, creating a massive backlog, if you like, or a massive set of data to trawl through and analyze. And thirdly, here in the aerospace industry, testing aircraft, each aircraft collecting, in this case, 3 gigabytes worth of data for every flight on 10,000 channels, mostly avionics data. Being able to trawl through that data might not be high sample rates, but there's a lot of data to trawl through. Also, in the more, if you like, traditional area, test and measurement, high quality test and measurement data. Here's a quote from the head of vibrations and dynamics, again from an aerospace company, saying, "Today, more than 50% of the working time of my team of dynamics experts is wasted in data archaeology and IT chaos. We would select a supplier that would enable us to find and use data more efficiently across departments, systems, and data formats." So I don't know if that sounds familiar to you, but in the, if you like, the more traditional test and measurement world, large quantities, high quality data can cause itself its own challenge in how to make best use of that data, extract value out of that data, and also cope with the fact that you've got multiple systems, different departments, people wanting to share that data. That can be a challenge. So recently, at one of our user group meetings, we had a user group meeting in Europe, engineers in attendance, and we did some interactive polling and surveys to get feedback. It's a great opportunity to hear from our users and customers what's important to them. And we asked, one of the questions we asked was this one: which do you think is the biggest challenge facing engineers in the next 5 years? And we gave them some options. And the options you see below are increasing quantities of sensor data and big data, which is what we're talking about today. Faster product development cycles, just getting there quicker. Rapidly changing technology, product requirements. In the automotive industry, think electrification, autonomous vehicles, driving some huge changes in technology that's making, providing challenges of itself. Better correlation between test and simulation, the drive to do fewer smarter tests, be able to sign off with as few tests as possible and do as much simulation, and how to make sure that those test real world results and simulation results are correlating. And then also doing more with fewer people, just the pressure of having to get quantity of data, quantity of analysis, quantity of work achieved. And the results were this. So that actually the most common response from our attendees was the first one: increasing quantities of sensor data. And so over a third of the attendees thought that was the biggest challenge facing engineers in the next 5 years. So clearly this is not a small problem or an isolated problem. So what are some of the customers as they look at volumes of data? So one is finding data that has already been acquired to avoid the expensive retesting. So like that quote from the head of dynamics that we looked at. And as he mentioned, avoiding wasting time looking for data. So on the one hand, avoiding having to retest because you just can't find the data. On the other hand, you know the data's there. It's just taking you a long time to find it. Connected equipment, we looked at that at the first example. Connected equipment is becoming more common, but the sensor data is stored and mostly not used at all. So increasingly, it's easy and relatively easy to acquire the data, store the data. The challenge then is how to get the value from all of that stored sensor data, some of which may be quite low quality data. It might be data of that might be unequally spaced. They might have problems or dropouts or bad values in it that need to be corrected. Because of that, there can be challenges in making the most of that data. So that requires us the ability to handle the volume, variety, and velocity of all the different data sources. It's not just one data source. People want to bring together multiple data sources and address those challenges. But it's not just an IT problem. It's an engineering problem as well. How do you take that data and put it into the hands of engineers so that they can, in the first instance, access it and start to work with it. But probably more importantly, not just finding the data, but the ability to gain insights from analytics. So be able to use that data and then be able to derive value from it through the right decision. So these are some of the needs. And what we're going to look at today is a solution that comes from our web-based product called Aqira. And Aqira helps engineers maximize the value of huge quantities of data through the use of data search in easily configured web apps. So that's where we're going to start on this portion. We're going to start describing what we mean by a web app. So You're all familiar with the fact that analysis itself can get complicated. There can be dedicated desktop tools for performing sophisticated engineering tasks. And those can be quite challenging to hand off to a less expert user. Hence, expert users tend to have to spend a lot of their time turning the handle on more routine analysis. So apps is a way of addressing that challenge, where they are an easy-to-use front end for what could be a very sophisticated analysis process. So with an app, what you want to do is ask a few simple questions that are relevant. In this case, for example, select some files. And you want to hide all the options you don't want the user to touch and just present the questions that you do want them to answer. And then perform the analysis and then provide the results in an intuitive and graphical manner. So an app takes something complicated and puts it in the hands of less expert users by hiding the complexity, showing the options you as the expert you want them to be able to use, that they need to be able to use, and then enabling them to view the results and interpret them intuitively. So let's stop at that point, and then so you have let's look at the software itself, and let's run an app interactively, so just so that you get some idea what it is that I'm to. So I'm going to jump out here. I'm going to go into Chrome. So here I'm running the Chrome browser, and as I mentioned, Aqira is a web-based product. So what I'm going to do is log in. This particular instance of Aqira is running in the cloud. It's running in Microsoft Azure, so I'm going to log in as a user. And then once I've logged in, it's going to show me a dashboard. Every user gets their own configurable dashboard. You can show results there. These are interactive results that you can work with. But in this demonstration, I'm going to go straight to what we call, under apps, the app list. So the app list shows me a list of available apps that either I've created or have been shared with me that I can therefore run. So here I can browse for different apps of different sorts, see a summary of what they are, and in this case I'm going to look for an app that helps me create a report for some measured time series data. So here's an app that has already been created, and what I'm going to do is move over here. There's some action buttons, one of which is just run report. So if I click that, it runs the app, it loads the app up into the browser, running this fully over Chrome. I don't have anything needing to be run on my desktop. And in this case, I'm just going to pick a measured data file. So this is a time series file. If you're familiar with ENCODE, you'll be familiar with S3T, time series measured data. I'm just going to pick a file, and I'm just going to hit next. Now, the next screen of this app is, okay, there's some report parameters. So it prompts me to add a name. I can put my name in here, maybe a location, and I'm just going to hit next. What it's going to do is it's going to run that analysis on the server side from that file, and this app has been set up to show me a preview of what are the histogram results, what do they look like. Well, I want to go back and say, well, maybe that's a bit coarse in terms of a bin size, so I'm going to modify my report parameters here, and I'm actually going to change that to a from-to diagram and make that, say, 64 bins, and I'm going to rerun that analysis. So it's going to take the same data file, rerun it. Now it's giving me another preview here, and I can say, okay, that maybe I'm happy with that as a histogram. I'm going to then press the report button. This then takes the file, shows me the report that's been generated. If I click on this, I can then, let's open that PDF up. And now it's taken that data file, it's gone straight from raw data. It's used the settings that I requested there for the rainflow count, the number of bins. It's put my name and location in the report. And here are all the different channels in that data file, automatically analyzed straight to a PDF. So straight from data to report, all in one app. As a user, I didn't have to understand all the settings were, understand how to use the analysis beneath. I could just answer a few questions and go straight from data to report. So that's a good example of how an app could help a less expert user do a specific task. Just effectively a self-serve app. So that's a if you like, that's a basic app, but it gives you some idea of, from an engineering perspective, how that could be used. So let's jump back into the PowerPoint. I'm just going to describe then what we mean by an app and how you create one. So here's a process for creating an app. So starting on the left-hand side, if you're going to create an app, you're the author of an app, what are the steps you're going to have to go through in order to make that usable for another engineer? Well, first of all, you have to think about what are the inputs and outputs. What are the things that I've got as input for my analysis? What do I want to calculate? What do I want out? Along those lines, then, the next step would be to then design any kind of interface pages. What questions do I want to ask the user? What settings do I want to expose to the user? And also, what kind of reports do I want to design or have output from my analysis at the end? You also then need to define the execution analysis. So what is the analysis process you're going to use? What are the options? Taking those inputs and outputs into account. Next step is maybe you need some in your app. Maybe there's some more advanced logic you need to put in there. Maybe some error trapping. Maybe making sure that if you like, saving the user from himself, making sure that there's maybe doing some quality checks. Might be some advanced checks you might want to put into it. Maybe using Python. Aqira, you can use Python scripting embedded into an Aqira app to help you do this. But as you'll see in a minute, you don't have to use any scripting to create an app. But that's if you like, an advanced option. Once you've got it to the point where you think it's right, obviously test it, validate it, make sure it's doing what you need it from an expert's perspective. Then the last stage is then to share that app with other users within your organization. And then within Aqira, you can either share that with individuals, or you can share that with whole groups of users. You can create groups and share those. So it's quite flexible in terms of how you do that. And importantly, on top of that, there's then version control. So once you've shared it, you can then, if you find there's an issue that needs to be resolved, you can then reissue that. You can even retire old versions of apps that you no longer want people to use. You can update it, and you can. So as the expert, the owner of that app, you can manage what other users get to run. So apps are all about making an analysis easy to use, but they're also easy to make. In the ENCODE parlance, if you can create an analysis process in GlyphWorks or Design Life using a flow, you're going to be expert enough to be able to create an app. And the way we do that is by using what we call an app designer, which creates the app using a drag and drop interface, and it does that for each step in the process. So what you see on the screen there in terms of settings or FE results file, each one of those is a separate step in the app, moved from top to bottom, moving through the app process. You can add some additional logic in there. You can add some jumps in there, but basically that's the default flow is top to bottom. So let's jump out at this point just to take another look at one of the ones with the flow app we just created or just ran, and see how that looks in the app designer again, so you have a feel for what we're talking about. And this is paving the way for what we're going to talk about next, with running data search in an app. So let's open up this app. Let's open this in the app designer, and here you'll see, if you remember the app we ran, we picked files, we input some parameters, we then did some data analysis, we then had a histogram preview, we then had the option to download the report. And this is drag and drop, so if I wanted to add another step in the process, I can literally just drag it in. And similarly with the interface designed, we can open this in the page designer, and that's probably, you remember the screen that was shown where you could input parameters. Again, this is drag and drop configurable by an engineer. So if you want to add another option in here or another field in here, you can go ahead and do that and edit these fields and tie that back into your analysis process. So this doesn't require any scripting. It's all completely driven through the graphical interface. So the app designer itself is really aimed at engineers to be able to create these apps and then share that with other engineers without it requiring a special project or development involvement or even any scripting. You can create a standalone app that can be shared with other people without having to do anything particularly complicated beyond what we think engineers can do. And the benefit of that is I think then you have a sustainable model of engineers creating apps for other engineers, maintaining those with a pretty low threshold of expertise required to do so. So let's look now at how data search is then integrated into apps. And I think the best way to do that is by looking at an example. So in this particular case, let's imagine we've got working with data from a new sport utility vehicle. So a sport utility vehicle has been tested at the proving grounds and run over various surfaces. And in this case, it's generated an additional 180 data files of various of two different drive types. So we've got various proving ground surfaces plus and events, plus we have two different drive types and two different weight conditions. And the data, the way that data is typically stored within our organization, has been put on a shared drive in the folder structure. In this case, the folder structure has been vehicle, model year, drive type, weight condition. And that works. It helps you to find the data. The trouble is you can't really easily look inside the files to find the data of interest. In this case, the data files are S3T files. Well, as we're just looking at an example of that. And each data file also contains other metadata, including a relative damage parameter. And in this case, what we've done is taken the data that's out on the shared drive, which Aqira can see, this Aqira is installed on a server, and that data has been indexed into Aqira. And we'll talk about what we mean by indexing more after we've looked at an example. So in this case, what do we want to do? Well, we want to do a data search where we look for all four-wheel drive unladen vehicle data. And we'd like to find the actual acceleration channels that exceed 20 G, so through some kind of impact event. So not just find the data files themselves, but actually identify and be able to analyze and report on the individual channels themselves. So let's jump back to the into Aqira. So here we're back in the web browser. And I'm going to reset my list of apps so I can see them all. And I'm going to look for apps related to search with a couple of different search apps. And I'm going to run this one. It says Vehicle Data Search. And once again, I'm just going to press this Run button. And what that's going to do is open the app in a separate tab within Chrome. It's going to load up the app and execute it. In this case, what we've done is we've designed the app, or the app has been designed to offer the user some search parameters. We have vehicle, so we have Olympia, Pegasus, and Hyperion. So we have these different vehicle types to choose from, model year. And we also have drive types. So, for example, before we were talking about it could be two-wheel drive, maybe we say four-wheel drive, and unladen. That was the requirement. That's what we were looking for. And we're going to look for where G levels are greater than 20. And this is going to do a search for individual channels that exceed this maximum. So I'm going to search on that, and it's going to come back with a list of individual channels. See the max value on these is all greater than 20. And I can do various things with that. The first thing I might want to do is, for example, hit View Channels and just show me the data channels that have been found, the 6 channels, the first 3 and the second 3 from these different events. The individual channels were identified. If I go back to my results, I might, for example, say one of the advantages of as part of Aqira is I could say do a predefined analysis that has been defined. So I click the rainflow button, and now it's actually created rainflow count of those identified channels, just the channels that met that criteria. So now I've actually got here the rainflow count of the channels that met that criteria where the max value was above 20. and I could then download those, and I'll just open them up on my desktop using a viewer. But that's the data files are now ready for viewing. Alternatively, I could go straight to a report, and before we had the example we saw in the previous app, I manually selected the files to stick into my report. Here, what I've done is I've run a search, and then I found just those channels, and I've put them into report. In this case, the data is grouped by test. It wouldn't need to be, but that's what it is in this case. So I open up this, and now it shows me the channels that, again, exceed 20G. And in this case, we've modified the report slightly so that it's showing me the vehicle and metadata information and the condition that was put in the search, for example. So again, go straight from search to a summary report. And of course, I can go back and change this. For example, if I wanted to say go and let's rerun this. If I go back to the beginning, let's go to my inputs. Let's say I want to find strain where my max limit was over 4,500. Weight condition. There we go. That's a good example of how you can use data search with a pre-configured design input, hide away the complexity of how to configure all the search, link it to analysis, link it to reports, and enable engineers to easily find data. In this case, it's just based on one condition that we've exposed, but you can get more complicated than that depending on how you want to expose that to your users. So let's look at the how we did that. So what we've done here is we've added into Aqira a new component. We were looking at the app components. Here we've added a data search component into the app. So this enables the author to design the search, and the way you configure that is through something called the search designer. And in that example we just looked at, the parameters for that search designer are actually passed in through that custom page. So you could set what vehicle you're looking for, what the max limit is, for example, on a page that the user uses, and then that gets passed through into the actual search itself. Let's take a look at how we do that in another example. So for example, here, if I just close that down, that was the app we just ran. Let's look at this simple example here, and I'm going to open up this example, and it's just got two components in it. One is the data search itself, and the other one is the output from that with a list of files. So this has already been started. This is in the search designer, and the first question in the search designer is, what are you looking for? Looking to return files or tests or channels. Now, files could be anything. Files could be data files, it could be images, videos. Tests are collections of channels, and within a file you may have more than one test. You may have some time series data, you may have histogram data, spectrum data. So tests are a collection of channels that go together, and then you've got individual channels themselves, which is what we were just searching for in the last example. We performed a search where we found the actual individual channels that met a criteria. If, for example, I say let's look for files, and I've got vehicle, model year, drive type, Olympia, 2019, and front wheel drive. If I just run that as it stands, and I run that flow, so I run that app, it's going to then perform that query. It's going to go and find those, and it can bring back a list of files. If I just do select all, it actually has brought back 90 files. So here I'm searching for files themselves that meet the criteria. And in this case, it's a pretty broad search. It's found 90 files. I could download individual ones, or I hit download there, it'll zip them all up, and I could download them. Well, let's get a little bit more refined. Let's see how I would replicate something more similar to what I was just doing in the last example. So for example, let's go back and open up that data search example again, open the search designer, and what I'm going to do now is I'm going to configure my search using the search designer by adding some more conditions. So the first field says metadata name. So if I start typing here, it gives me some options, some predefined options I can choose from. For example, the file name or the extension, very common, obviously default attributes for a file. It could be related to, as I said, to a video or an image file. In this case, though, I'm going to go a little bit deeper, and I'm going to start typing and seeing what metadata there are available. And there's a condition metadata, which is what I was looking for. And again, I can say where the condition equals, in this case, unladen. So that's on the file level. I can also put conditions on the test level or on the individual channel. So in this case, I could say, again, some default options, channel name, units. I can say where the, say, max value is greater than, an example we just had was 20, if you remember, and where the units of that channel equals G. So that's how I'm going to specify the type of data was. The units was an acceleration with the units type of G. And it's going to now look for files that meet these criteria at the top, and also where it contains at least one channel where the channels that have units of G, where the max of that specific channel is greater than 20. And I can actually add other channel criteria onto this as well. So I can make this more sophisticated criteria. So if I do that and I say done, so I've set up my criteria in my data search, and it should then pass those results into the file list. I hit done. If I now run this search, it's going to come back. It's actually come back with the 3 test files we saw in your example. It's just, but instead of bringing back the individual channels, now what I've asked it to do is bring back the whole file. So I've just selected that file to download. I'm going to open it. And here you see all the channels are present, including, you see this channel 3 where the max is over 20, but all the other channels are in this data file. So that's an example whereby you start to see the flexibility of data search within Aqira. You can either look for the files themselves and find all the channels that are in that file where the certain condition was met, or as I said, you can look at individual tests or channels from that file. Let's clarify some terminology that we're using for this. So that's an example. So what we were doing there was finding data using metadata criteria as part of an app. So by data, we mean files, well, that could be data files, engineering data files, test and measurement data files, CSV files, be any file like an image or a video. And data can also mean tests, where tests are a group of channels for supported file formats. So that might be a time series data, or maybe histograms or frequency spectra in groups of tests. And then within those tests, the individual channel measurements or results. And then the metadata themselves are the values that are extracted from the data. So, for example, that might be metadata that is within the file, or it may also be metadata that is derived from Aqira at the point of indexing, and that can be the manually specified. Indexing this file, I want to manually give it this piece of metadata. It might be a name, it might be a project number, it might be an engineer, it might be a location. You just want to add that metadata in on the fly. You can do that. And also, if from data files that we recognize, we have the option to actually recalculate things like statistics on the fly as the data comes in to calculate some statistics metadata. Now, the settings on that are optional, and we'll just touch on that in a moment. But the important thing then is that apps use these search results in analysis. So it's one thing to find the files, that's great, you can download it. But as we saw in the earlier example, you can also take those search results and put them automatically into further analysis steps that are either automatically or manually started. I mentioned the file indexing process, so let's talk about what that is. So data is indexed into Aqira, which means the data itself is not moved. The data is left wherever it is on the network. It has to be accessible and visible as it's indexing it. But the data is not copied or moved or replicated. It is pointed to. And so that can be an attractive way of working, especially with data you already have lying around or data that's already being managed proactively even within your organization. This is a way that you can then look into that data, extract information from it, and actually find useful information within it without having to actually move it or duplicate it in any way. And then the metadata is extracted from the files that are recognized. So it has to obviously understand what that data file type is before it can then work with it further. And this is how it does that. So we have a file indexer. All files go into that. All files are looked at, and all files get certain standard metadata attached to it, regardless of what that data file is. That file then goes through what we call a file categorizer, which tries to determine what type of file it is and what can be done with that file. And so that then will derive additional pieces of metadata, which then goes into the database. And it's important to note that that metadata is controllable. So at the point of indexing, not all of that metadata needs to go into the database. You have control. The administrator who's doing the indexing has control over, is it everything? Is it some of that metadata that gets put in? And so that is controllable. The database itself within Aqira is stored in a combination of a traditional database tables or SQL type tables. But also importantly, we're also using a NoSQL solution for storing of JSON objects that define the metadata. And the reason for that is the fact we don't really know in advance what these metadata items are going to be. Therefore, it's a very flexible system. It needs to be able to cope with new metadata coming in all the time. It's never seen before. And so hence the need for unstructured NoSQL approach to storing metadata. But the nice thing about this solution is it does that searching jointly. So it does a combination of, with standard SQL, searching where the file test channel structure is stored in more traditional tables, but this metadata associated with it is in a more flexible NoSQL approach. So really bringing together what I believe is the best of both worlds and giving great performance as a result. Related to big data, one of the topics we talked about at the beginning, obviously trends towards an increase of volume, variety, and velocity of data coming together. So the term big data is often used even in engineering circles. And I encourage you to check out this new white paper that we've done on big data analytics in engineering applications. And so we've added brand new capabilities in Aqira. Here today we've talked about search, but very closely related to this is the ability to then perform data analytics upon that. What we did in the demos today was very straightforward, but easily there is needs to, or there's the very common need to go beyond that into very scalable analytics, especially on time series data. And in that context, we've created a Python callable analysis framework called EncodeDS. And this is a brand new analysis product. So I encourage you to go to encode.com/EncodeDS, check out the white paper and see how that capability enables us to couple these two things together. Data search, but then feeding into scalable data analytics. So that's something for you to check out. So let's look then at data search in Aqira. Just to summarize then, what we're talking about here is the increasing volumes of sensor data, and the finding of that right data is increasingly challenging. And the measurement data that already exists in your organization has a high value. There's a whole lot of cost involved in generating that data. And so not making best use of that data is clearly wasteful. Additionally to that, there are also opportunities that are that are arising from making better use of connected equipment data, like the example we saw at the beginning of the automotive OEM. That enables you to then understand how products are being used by real customers to help you drive a better test, a better qualification, a better understanding of how new products should be designed, and maybe even understanding where and why the warranty problems you've got right now and the costs associated with that, but better understanding of how products are used in the real world. So that's increasing volumes and new opportunities. Secondly, we looked at data search within apps, and this enables us to find data directly for use in analysis processes. And the important thing about apps is that they're easy to use, and they also have to be very configurable. And this enables less expert users to easily find the required data by bringing these two things together, apps and data search. And lastly, flexible searching on metadata. And we're doing this by using indexing of the data files with a very configurable metadata extraction, so that metadata can be either extracted that was already in the file, manually added, calculated on the fly, and the administrator has a choice of what of all that metadata actually gets added into the database, and then enabling, by using that combination of SQL, NoSQL, powerful search down to the individual sensor or channel level, not just finding a file or files, but actually being able to find individual channels that meet that criteria. So in summary, data volumes are increasing. Challenge is how to get value from all that data. We saw in apps in Aqira are easy to use by non-expert engineers, and data search itself in Aqira is powerful and configurable to address your specific needs.